Hey YouTube, it's Anthony with you on this channel. We're going to continue our harness project. This go round we're going to add the relays, the 4 relays in the drawing that we need. I am going to be making the O2 harness in this one also. In a previous video I left a comment in the comment section about the O2 harness. If you have the harness with your harness, keep it by all means. Please don't butcher that one. They are specific to the transmission. So if you're running an automatic transmission, you must use the automatic harness, the O2 harness for the main harness. If you're running a stick, you must use the stick O2 harness, part of your main harness. If you don't have that, no big deal. You can make that section and I'll show you how. Alright guys, we're going to talk about the relays that we'll need. And the first thing that I want to talk about again was just like our ground. We want to make sure that the power wire to feed the power for our relays is big enough. Now, it doesn't specify in the drawings what size wire you should use. I'm going to say at a minimum, your power wire should be 12 gauge. Same with your ground. This is just my beliefs. You can use the factory color and grounds and whatnot if you want to. I'm not saying it's right or wrong, but I tend to overdo things a little bit as a safety deal. So with mine, I'm going to go with a number 8. And you're like, damn, that is a large wire. Yes, but there's a reason. I'm going to end up putting another relay with my stuff that will feed an electric fan later. The beauty of doing your own harness like this is you can add anything you want to that may be on the engine side or just the engine bay area. You know, you can do big lights if you want, you know, like if this is going to be in a Bronco and you want to run like a big LED bar or several LED bars, you can use the same power that we're going to run through here to power your relays for your LEDs. If you're going to do, you know, electric fans, you can run the electric fans off of it. And there's really anything you want to design in there, you can run into this area and use that power feed, so you don't have to have 8 different positives and 12 different grounds, you know, throughout the thing. If you put a large enough one in here, we can tap off of it and use that. So I have, again, a number 8, and I'm just going to show you for an example. There's the 10, the ground is a 10, and that's the number 8. This is not cross-linked insulation. I really struggled to find a piece that had cross-link. It is a it is a silicone jacket, and the silicone has a very good rating also for the temperature it can handle. That's why I went with it. I would have preferred cross-linked only because if you look, I'm going to show you, if you look close, the insulation is really thick. I was hoping for something a lot thinner. It would work in our harness better, but it just didn't work out. So we're going to go ahead and run this through our harness and have it sticking out here, and then we're going to come off of this with smaller wires to feed our relays. All right, we've got our relays. I'm going to go ahead and put one together so I can show you how they are. So these that we have, I like these because the nice color coding. So we're going to pull this apart. You can see how they've got 4 pins and one of them skewed, right? So the top and the skewed one and the one right above that, that's going to be the power that's going to be switched through. So the power would come in, and when the switch closes, go out. So the beauty of it is with the fuse on top, the red is going to line up, and voila. I'm also going to go ahead and put these little tabs on. They just slide in the top. And I'm going to lay these out. This is just a scrap piece of plywood that I have. It's painted gray from a cabinet project that I had. And it'll work good as far as a layout. I'm putting this tape down so we can label these and keep these from getting messed up as we do these. So go ahead and get your relays put together and laid out, and then we will label it all and get it going. So excuse me, it's allergy season here and I am feeling pretty rough. So again, we're just gonna take screws and screw these to the plywood so that we have something temporary that we can go by on this. So once you get these built, go ahead, and it doesn't have to be exact because we don't really care. Now if you're doing something to where this would be in the vehicle, see, you can make something fairly nice and put this to like a piece of metal, sheet metal. It could be bent however you want to do it, and this part could be mounted with the harness and the computer up under the dash, behind the seat. Sky's the limit of where you want to put this. So go ahead and get that together, and then we will be connecting our power wire and so on and so forth. Okay, so we've got our relays laid out, and I just screwed them so that they will stay in spot so that we can get this together. Also, it may be upside down for you guys, it may not be. I labeled mine. Here is our mass air or O2 relay, our fuel pump relay, our ignition power relay, our EEC relay. These two are not required, but the way that I'm gonna have to do the neutral safety switch is through a relay. I'm running a 5-speed in this vehicle, and I'll explain that in a little bit later. And also I'm gonna have a electric fan, so I'm gonna go ahead and put my fan in also. So if you don't know how a relay works, it's essentially a switch that can handle a lot of what we call load. The load is the power that's used in a circuit. Just a regular light switch like on your car, and you turn a light switch to on. If the power ran through the switch, and it's happened before in vehicles, it can overheat and shut the lights out. It's not a good thing when you're driving and your lights go out. So years ago they started developing and using relays. So the actual switch would just turn this over, or like a heavy duty switch, which is inside this box, on to let the electricity flow through, and you would not overheat the switch. So there's essentially 4 wires. You can have a 5-wire one. You've got your power, which is the power in. We're going to call that our red one. And then our load, which is going to be blue. And again, if your relays aren't the same colors, there's a way to tell, and there's numbers on them. So if you look at the top, I don't have one, maybe I do. If you look at the top of the relay, you'll have essentially, it looks like a square with those slots, these metal slots that I showed you on it, and they'll be labeled 87, 86, 85, and 30. So 30 would be your power from the battery. 87 would be to the device, or what we call the load. Your 86 would be the switching power, the the switch that turns the relay on. It can be a key switch, a push button, a toggle switch, any type of switching mechanism will turn these on. And then last is our chassis ground, or just ground. So it should be black in almost any case. So once you've got those figured out what you want to do, now we're going to start putting the pieces in place. Remember, we saved this ground off, it's our heavy one, and we're going to tie all of our grounds together. So go ahead, and I'm just going to splice this piece into all these black. And what I'll do is just do it like this. I'm going to go through and splice like we did onto this one. Cut, splice, another one, another one, another one, another one, another one. Once we get to the end, your very end one, you'll just want to put like that. So what I'm using is I'm going to be using butt splices on this. Since we soldered the other stuff, I'm going to butt splice this so we can show a different form of how we're using it. So let me get my materials together, and we're going to go ahead and connect our ground. After that, we're going to connect our hot, and it's going to be essentially the same way, except for I'm going to be soldering this thing, because I don't have one long enough. Now when I get to the end, I've got a number 10 piece that will just solder to the end and tie the last two. There's no reason to take this big chunk and try to solder it a bunch of times. It's like I said, it's large, and it's kind of hard to solder with the heat we're doing. Now they do make splices, crimp splices for this, where you literally would just run a ring after you slip the insulation off, and you would put your wire on there and then crimp it down, and then you would use heat shrink over top of it, because it is a uninsulated splice. So we'll do that in just a second. Okay, we got our grounds. We're going to go ahead and get started. I'm going to work this way to this way. No rhyme or reason, just the way I'm planning on doing it. So, you know, the other thing I was going to say is you can do 2 into 1. I think just to save on splices, we're just going to do 2 into 1. It'll be like this. If you can see that, I'm sorry. I'll do these 2 and like that. It'll save us splices and time. So we'll go ahead, and don't know if you understand the colors on the so any of our crimp connectors, butt joints, spades, rings, terminals, whatever, they're color coded, you may know. So this one has it written on it. This is for, I'm not sure if you can see that or not, 10 to 12 gauge wire. This one is 16 to 14 gauge wire. So what we're using here, these are 16 and this is 14. So go ahead and trim this up a touch. We don't want to have too much sticking out. There's no real splice orientation of how much wire we need on with these. So you can try a couple times. You know, if you stick your wire in and you're still seeing some insulate or some of the wire, you want to go ahead and make that a little bit smaller. So put it in there, and you want to squish it down and try it out. So some of these, they'll tell you the die sizes. The die is the part that does the crimping. Some of them will have a little dot that'll have, you know, yellow, blue, red, and those will correspond obviously with these butt splices. So for our second splice here, I'm gonna have to cut this. I'm gonna take both of these wires and we're gonna splice it into here. So once you get that in there, go ahead and splice it down. And there you go. You got one, then we'll do another one here and another one here. So we'll have 3 joint splices just like that here. So again, just like with the soldering, you don't need to watch me do this 6,000 times. So I'm gonna go ahead and do all my grounds, and then I'll come back and we'll start on something else. Okay, I've done my grounds, and let me get some of this out of the way. So you can see how I've done them. You'll notice that one of them's not connected. That's my fuel pressure, I'm sorry, my fuel pump relay. If you look at the drawing, our ground, so to speak, is our blue and orange, which is EEC pin 22. And that's right here. So test pin 22, fuel pump. So we can run that over here and make that connection. I'll do that one real quick while we're on here. If you guys are new to this video series, in the links, there's always a link to the drawings that we go off of. So just look in the link and you can open up the link for the drawings. There's a couple other ones. One of them's just called useful information. It gives some great places to look up wiring information and so on and so forth. So now we've got our pin 22 done. I'm gonna kind of hide that in there a little bit so it's not in the way. Okay, so now that we've got that done, I'm going to do the power side, or in this case it's going to be all of our reds. And it's going to be pretty simple how this is going to work, because all of them are going to be the reds to reds, with the exception of, and again, this is just my harness, yours can differ, is my NDS relay. So instead of using power through my relay, I'm going to use ground. And you're going to be like, what? Makes no sense. The relay is just a switch. You can switch anything through it. You can switch power, you can switch a ground. If you could switch a telephone line through it to talk to somebody, you can do that through that. So you'll notice that I've already tied my ground to the blue, which was the load side. So this red one will actually go to, and I think it's actually called pin 30. I'll look it up, but I'm pretty sure it's pin 30, which is the NDS circuit through the harness for the neutral safety switch, is what I want to call it. Pretty much just tells the computer, hey, I'm in neutral, you can start. So next we're going to do is, like we were talking about, we're going to take this cable, and again, pick and choose your size. You know, I've got a 10 that would have sufficed. I mean, you look at the difference. A 10 would have been fine if I was not doing my fan relay. Like again, no smaller, please, than a number 12. Most of these do not have that much load on them. I know in the drawing they show like 15 and 20 amp fuses, which in my eyes is overkill. But you still want to make sure that you have enough for the supply that's going to be there. If you're running an aftermarket fuel pump, it could be pulling 15 amps. And you're like, well, that's still not a lot. Well, once you add this amperage, this amperage, this amperage, and so on and so forth, you may be exceeding the capacity of the wire. And what happens? That's when we get fires. So I'm gonna go ahead and I'm gonna do, again, it's just gonna be like we did in the soldering one. I'm soldering this one because I don't have the crimps. So it's gonna be like that, and we'll do 2 splices just like on the other one. I'm sorry, 2 of our relay splices into one of that. That way we don't, like I said, have too many splices, and it'll save us time with 1, 2, 3, 4, 5, 6, and so on. So I'm going to do this, and you, again, don't need to watch if you want to fast forward, I'm just going to do the one, and then we will go on to the next one. So let me pull off my thing, get my heat shrink ready. Anything on the power side has to be insulated. There is no ifs, ands, or buts. We don't want any dead shorts anywhere in our electrical system. It's only asking for major trouble. We don't want to be burning our car down or our truck down or dune buggies or anything that we're making this for. That's the very last thing we want to do, is have any electrical issues in our vehicles. That's why, again, I overdo things, some people say, but I won't have a problem either. And the price of materials is very, very minute. You know, a number 10 wire, like on the ground, you can get 12 foot of it in certain places for $8. You know, number 12 might be $6. So if $2 is too much for that, then maybe you need to look at another budget on your vehicle. I'm not one to really heart people for their choices, but I surely would not want to spend all the time and effort to build a hot rod and to have it being destroyed by $2 choice. Make your choice however you would like to. I can't do whatever choices, can't make those for you. So here we go. I'm got that together. Now, with the last video, somebody sent me an email and was telling me a different way of how I connect, how I just twist my wires together, and they suggested a different way. Is unravel your wires, and you would literally fan them out, and as you fan them out, interconnect them. So like you can stab them together like that and then twist them. So I made a couple of them, and I'll be honest with you, it works pretty good. You can tell it's a much flatter, I guess would be the best way of saying, connection, because you can get all of them wound pretty tight, and they're mechanically sound, like we talked about in the last video, if we want to make sure that they're strong enough. So I thought, you know what, somebody told me that, I want to pass, this is an education video for all of us. I don't do this for any money or anything along those lines. I'm just trying to do something that is going to help everybody. I mean, it's definitely helping me by doing these videos. I'm getting to talk to some cool people and throw some ideas around about after this series of videos, what are we going to do? Am I just going to be done with it, or should I try to do something else? Throw some ideas out there. If you guys have something that you're like, man, I would love to see this done, I'll see what I can do. Let's keep it with the electrical field, specific to cars or boats. We can do a boat, we can do motorcycles if it's something that we can do. Just throw your ideas out there. Again, this takes a lot of heat on these larger wires, so bear with me on this one. Okay. There we go. So we'll let that cool down a minute. We'll slide our heat shrink on it, and I'm gonna give it a little more time to cool down. It's still warm. So we'll slide that on there, and we will then, excuse me, we'll then melt that down with the heat gun and rock on to the next one. So, oh man. Some of these are just a little bit too small for that 8. I'm hoping this doesn't mess up here. Come on, baby. I like sweet talking it sometimes. There we go. I think you're gonna work. Well, it started melting down. So I'm gonna have to slide this on from this side. I've already pulled my wire through the grommet. I'm gonna have to pull it out and put another piece on, but sorry for that. Anyways, we're gonna do, again, like I said, we're gonna do these 2 middle ones together and the last 2 together, and we'll be done with that. Okay, so we got our power in now. You know, what's this yellow? Well, excuse me again. So the yellow is our memory power to the EEC. So if you look at your drawing, the EEC relay, you would come off of the fuse, right, and right there into there. So now we're going to get into the control side of it. Remember, these are the switching sides. Not all of them go to ground, but some of them do. So we'll just splice into there if it needs it. Some of them switch off of another part of the EEC. So let's start, first things first, with the mass air and O2 power relay. So we have our power in, right? We have our ground for the switch. This is going to be what controls it, what turns it on and turns it off. This is going to be our load, which in our case is our large gray and yellow wire. So we've got that feeding around. I'm going to bring it so we can all kind of bundle in this same area. So again, like we talked about, just going to splice it with a butt splice. So these are larger wires, 12 gauge as a matter of fact. So I've got some of the yellow butt splices, and do that here in a second. I'm leaving everything labeled and long. We can, if we have to, we can fold it over in our harness. This part is going to be, again, you choose a place, but let's say under the dash, behind the seat, another area. Make sure your wires are long enough to make it to wherever those areas are. We don't want these to be too short and then have to splice again, because the more splices that we have, the more chances for a high resistance connection. Anytime we have that, we have high current flow, we have pop fuses. So now we've got to find our green and yellow. And I know this one is green with yellow. That's our fuel pump signal, so we're not looking for that one. It's gonna be, where are you at? Where are you at? Did I say green and yellow? I'm sorry. It's red with green. So I'm barking this up the wrong tree here. Okay, here we are, red with green, which is on our old EEC relay. So I'm gonna snip that out. And we're going to bring that around to where we can get to it. Okay, so obviously it's kind of short. Probably gonna splice a little end on it, but I want to tell you, so our O2 mass air O2 power relay, our fuel pump relay, our ignition relay, and this side of the relay is going to be off of this one. So this is the ignition switch run. So when we turn our key one place, that's run. We turn it again, it engages the starter, that would be start. So anything that's going to be when the power is on. Again, our O2 relay, our fuel pump relay, the ignition relay, and the EEC relay. So all of these are going to be connected to this one wire. So we'll probably butt splice it like that and be done. I think I'm gonna just make this a little bit longer. I made the yellow longer to reach. So let me see what I got here. Let's go with pink. So on our signal, our white, the drawing shows ignition switch run. So this would be hot in the run position. Like with a key, you go stick the key in, turn it one time, that's run, and then you would turn it again, that would be start, and then it releases, still on run. So I selected pink. You can use any, if you want to use some of the old wiring that you had, go ahead and use that, but it needs to be at least as big as the original wire. So I got a pink, and we're gonna let that in that bundle there. So now we've got excuse me, our power, our 12 volts for our relays. We have our grounds that need to be ground. We have our signal test pin for our fuel pump. So to fire all of our relays, we needed a switch, right? Our white is our switched wire. The wire then question is, it is our ignition switch run, which essentially is our key switch. Key in, one, that's run position. Twist it again, that's the start position. So what I did was I connected a pink wire to that, and I'm getting everything in a bundle, and I labeled it hot in run. So we'll know that when we need to take our wires to the key switch, this will be hot in the run position. This is starting to get a little mess. I'm gonna have to take a minute here and bundle these up just a teeny bit so that I can not be bothered so much. Okay, so we've got our signal wires, our switch wires for our relays done. We have the grounds that need to be done. We have our power that needs to be done. We have our first one was the test pin 22 that is connected to our ground on the fuel pump. For our load side of the fuel pump, that will be this green and yellow that says fuel pump signal. So I have a piece of green. I'm going to connect the green to green. Green to this load wire. I hate making all these joints, but I mean, obviously you can tell this is not going to be long enough. So I'm glad I bought all these extra wires now. I can just quickly make this. This is going to be, again, a solder joint. I'm not going to put a bunch of crimp connectors in there. Let me save this here. So we're going to relabel this one when we get this over here, fuel pump signal. So it shouldn't take very long. Get a little bit of heat shrink. Again, guys, if you're tired of watching soldering, I understand. Just go ahead and fast forward, and then we'll be on to the next one. Damn it, you have my finger. Okay, now we're gonna run the fuel pump load side. According to our drawings, it's green and yellow off of here. This is our signal to tell the fuel pump, or signal, I'm sorry, that the fuel pump's running. My wire wasn't long enough, so I soldered a piece of green. Our wire is green with a yellow. It's a fairly large wire. Green with yellow, so I soldered a section on there to go up. I labeled this side fuel pump signal / pump. So I need a wire here. We also need one for the pump. So I'm taking this other green and I'm going to take that one to the pump side. So we'll get this crimp going here. Get that on our relay load wire here. Don't come out. I'm not left-handed, guys. Apologize. Just 2 hands on that one. Okay, so that's in that bundle. I'm labeling the other side, and again, this wire, is a 14 gauge wire. It would run, I'd say, I have to look at my thing, but my guess would be about 15 amps worth of fuel pump. And short of a huge aftermarket one, I think you're gonna be fine. Double check all that. There's tables on the internet that show what size wire for what on. Remember, we're running 12 volts DC, so don't be confused with any house wiring. Okay, so I'll label this one fuel pump, and I'm putting a positive on there because a positive sign, because that is obviously the 12 volt side of our fuel pump. And put that out of our way. Okay, so again, to recap, we've got our hots, our grounds, our signal. We have got our test pin to the ground of the fuel pump, so that's fuel pump side is done. Our mass air O2 is done. We've got the gray and the yellow on there. The gray and the yellow is our HEGO power mass air. Okay, so last 2 that we have is our ignition and our EEC. I'm not going to worry about these 2. Those would be done after the fact. So next on our list, ignition relay. We have our ground connected. We have our ground connected. We have our power, our 12 volts connected. We have our signal wire connected. So last on that one is our load. So for our ignition, our load is red with green. So remember, the red and the green is the power at the distributor. And it said in the drawing, the red and the green was hot in run, and the red with the blue, which we extended in our last video, was hot in start. So let's find our red with green. We got that right here, and it's gonna be pretty close to long enough here, so we kind of get this going. Get a couple more little splices, butt splices. Again, blue on this one. These are smaller wires on that. Check them. We'll make sure we don't pull any apart. We can always redo them if we do. All right, so now our ignition circuit, our relay is done. We've got the load, which is our red with green. We have our signals, which is to the pink we added, which is hot in run, for power, and our ground. So now our load is for the EEC, which when we look at our drawing, it's red, and that one goes to the EEC pin 3757, and it powers up several things. We're gonna have to, I'm gonna flip this over a little bit because if y'all recall, this was the one that had this gigantic bundle of wires here that were all red. We're going to kind of tap into this. Just pulling it enough to get this cleaned up. This is, you'll notice our EEC right here. Relay, our old one, the yellow, we don't need. The reds, there's our relay. The yellow was the power in. We're gonna pull that out. And that's done now. We'll leave that there. So now we need to connect our reds. We already have one that goes to 57, so we're going to do this a splice here, and then we'll splice in our red from here over. So I'm going to go ahead and cut this out. I'm making this splice a solder joint because you're going to have a lot of different wires in here. So let me cut some of this out. Okay. So we've got these two went to 57 and 37. These two go into the field side to power up any of the devices out there that we are using. And then we'll need our load off of our relay. So voila, we got a red. And I'm just gonna lay this out here. Go ahead and do my splice right, or my butt joint right here. So excuse me. That. red. And so I'll bring this around in our harness here. So I'm going to do a solder there and there. And that will, I would love to do one, but that's going to be what we'll finish up with. Once that's done, then our relays are done. And we'll work on the harness for our O2 sensor. So unless you want me to watch me do it, I'm gonna go ahead and do it. And if you guys are interested, you can watch it. If you're not interested, go ahead and fast forward. So, shrink on one side. Oh, wrong side. So I'll put that on after the fact. Guys, leave comments in the comment section for me. Tell me if you're enjoying the series or think I'm not really capable of what I'm doing here. I always use the comments and we'll curve the videos to everybody. Again, I'm doing this so that it may help somebody. There was nobody when I was wanting to do, I did my first one, there was nobody out there doing any type of real documentation. There was a lot of talk on the internet about doing it, and all you need to do, just do this, do this. I knew it was possible when places like Ford Racing and Painless Wiring are making their harnesses that to me didn't seem like it had any special connectors or resistors built in to do the, you know, to do the hot rod. I think they called them something like a hot rod harness or similar. I know you can download the installation manual for the painless wiring one. That's kind of what I looked at that to do some of the documentation and figure out, you know, what all I needed. It just goes by telling you some of the connections that you have to make on your own, some of the connections that are there and where they would go to, such as, you know, like a mass air relay or something along those lines. So again, I knew that it was possible, just needed to figure out how. And my twist came undone. Yeah. I need those little hands to help me out. I don't have my helper with me today. He's playing video games, I'm sure. All right, let's get back at this. got a little sharp point here I want to try to keep from poking through. There we go. Let that cool down a minute. Let that cool down a second. So I'm going to go ahead and get all this kind of bundled up here while I'm waiting for that. Cool down some. Glob of that solder there. Damn it. I think I used too small a piece of heat shrink. Yep. Shit. Okay, well, to get us through this video, we're just going to put some tape on it. This is not what I prefer, guys, but I don't want to short anything out, so I'm not going to even try to attempt to heat that just yet, either one of those pieces. I think I'm going to undo this and redo that.